Yeah, hi, good evening, everyone. I hope you are doing good, and thank you for giving so much support to my last video, which was on the target malware analysis. This time, we will focus on something which is, which is in right now is in very much news. One is the Medusa, which we will discuss maybe in next coming videos. Medusa ransomware. But in this video, we are going to talk about something which is the Agent Tesla. So Agent Tesla was a very was a very old exploit which was like identified during the CVE 2017-0199. But nowadays again it has been in the news for so much time, and in January, one of the known organization was being hit by that. So we did the analysis over there. We performed the IRs. One of my friends, they performed the IRs, and we did the malware analysis on that particular exploit. So how we did the malware analysis? We used a similar set of tools that we used last time, but we did some modifications in that. So I will demonstrate what we have done in that uh, exploit. So I have downloaded the exploit from the same malwareanalysis.net. So you can go ahead and you can go ahead and download the sample from there. So I will just go to malware samples, and then I will go to CVE 0199. Now, don't look to these files. These are all after the analysis. We will see how we got up to this and what we did in that during the analysis. But this is the PK file which we downloaded, from which we checked it from the uh, uh, from the malware analysis. So we will see how we can do the analysis on this. We'll use the same D shell. So very first thing, as I mentioned in the last in my last tutorial, that we will definitely we will start with the DNS analysis. So if you see that the current connectivity is from this machine that was identified on 9th January at around 12:41 p.m. and uh, the connectivity is from 10.19.101 to this. But the main thing is to check that these are the uh, domains to which the system was trying to connect. Then there is something interesting that we identified immediately, that a connect that something is going on FTP, and from here all our doubts getting started that this agent Tesla is again doing all the data exfiltrations. So how we reached up to collecting all those IOCs that are there. Palo Alto has done a great job, which is Unit 42. They have done something good job in this. They have identified a lot of IOCs, but I will go through step by step how we identified the IOCs and what we blocked immediately. So we immediately came to know that these are the four domains that we have to focus on, and in few steps you will identify more about this. So the next thing that we ran was the net flow. That what is the current net flow and from which countries the net flow is going on. So we ran it, and we identified that the most of the connection is being made to the US and on these public IP addresses. So we check that what could be the top talkers. So these are the top talkers in this, and we see a lot of data which is being circulated to this IP address, this IP address. So if I say that these IP addresses have caused a lot of data exfiltration, there must be a lot of data that that must be going on these IP addresses. So let's try to identify what is a large flow that has been sent onto what IP address. Mm, uh, this is correct. Yeah, large flows is fine. So this much of data is being sent on this IP address to US in 17 seconds. So this is our prime target where the data exfiltration has to be stopped immediately. So we immediately block this IP address on all our security solutions. Means not our, basically the organization's security solution, firewalls, EDRs, you put it on your web proxy, anywhere, wherever you are identifying, you have to put the IP address and immediately start scanning your environment with this IP address. So anywhere where the connection is being made, it should be immediately stopped and cleaned. So let's dump the HTTP dump to identify what is going on. So if we see the patterns over here, we can check that get request is being sent over an Apache server, which I think XAMPP server is installed to connect to the Apache web server to download the HTA file, which is the uh, seam best things ever. Then another get request is being made to a different server to download the Visual Basic script, and another request is being sent to the same server to download some text file, and then we get another request which is over here, and we started blocking all these IP addresses immediately because we know that something malicious is going on here. For this, we were not sure that what exactly is going on, whether the server is creating the request or whether the this request is created by the malware. So we went ahead and we did the follow stream onto this. Okay. So let's go up and check what we have identified. Let me just check if we can run more command with this. Yep. So if you see that a connection string is being made and some truncated data is being dumped onto the machine, which looks interesting, but at that time we have to stop the attack, so we didn't focus much on this. We only focus on something what is going on in the network. So you can see another connection is being made at this time to this IP address over the 443 port, and the source port is this. And we went ahead, and here is the HTA file that was being downloaded from from this particular IP address. And this is the HTA file content, which is the encoded JavaScript content, which we decoded, and it was further which is completely right now obfuscated. We deobfuscated this content because this is written in your URL encode, but and then base64 and some other logics we applied, but it was very hard to guess the strings. But I will show that where till where we were able to reach out in this. So this is the HTA content, which is nothing but this. But here is something that interesting that we have identified, that some username admin is being called out when a connection is being made over here. This is the name of the desktop. This is the Windows 11 Pro, and over here a connection is being made to accounts.google. I mean, not connection, but something is being truncated onto this particular domain, and a username Gracie is being used with the password this. Okay, if I'll see, this is the password of the username Gracie Hoffman 24 at gmail.com. Then uh, uh, then another request is being sent on bbc.com, and the username and password being used over there. I think these credentials are being dumped from the browser itself. I think the person who was being compromised, her credentials are being, or maybe he or she's credentials are being saved in the browser. So I think from there these are being dumped. But interestingly, because this is Agent Tesla, so interestingly, we were able to identify a lot of stuff. Then something else is also there, which is using the Thunderbird. I think this is the Thunderbird email client that is being used for email communications, and and Gmail is being saved as the SMTP server onto the Thunderbird. Then we dump the Visual Basic file, and this is all encrypted encoded data which we ran it a complete scan. And if you see that it is that in that that after that this has tried to connect to rest cloudinary.com, something very interesting. And it took a lot of time further to guess the things, but let's go something too interesting that we identified, that what is going on in the environment at that time. Okay, let me just scroll it a little bit. Let me quit. Let me just recap. Okay. So after this is nothing but a text file is being downloaded. Then we have another connection which is being made to ipapi.com, and here is something that interesting is going on this IP address. And on this particular server, the data is being exfiltrated using the FTP connection. So here is the username that is being used, and this is the password for the FTP server. And here is your Windows 11 PC that was for particular user. And here is all the data that is being uh, exfiltrated. So this is how we were able to identify the exfiltrated data that was going on in the environment, and we immediately blocked the IOCs over there within a few minutes. We blocked the IOCs, and we ran a complete scan in the organization, in the affected organization, and the zone was completely isolated. But we didn't stop there, as you know, the incident responders and the malware analysts, or the uh, digital forensics or data forensics guys, they never stop anywhere. They go ahead to identify something which can be, identify more. So we ran FTP, but we didn't find anything related to FTP. But you can see in the follow screen we were able to identify. So always remember that when you're using the decode plugins, you must use maximum of the maximum plugins to identify the ongoing activity in the environment. Then we use the web to identify the files that are being downloaded from where and this is where we were able to identify this. So let's dump all the files, which is using decode minus p rip http, and we will download all the files. And if you see, if you do the ls, now a third copy is being made, but you can consider it, the files are being already being there. So these are the IOCs that were captured. These are the Unit 42 IOCs, which we have already showcased you that what exactly happened. An email came to them, an Excel file is being downloaded. Excel file made a connection to HTA to download the HTA file, which then further downloaded the Visual Basic, and it downloaded the JPEG file with embedded information. And this is your GUI loader, and then you get the agent Tesla style FTP data exfiltration. So this is how this whole vulnerability is being exploited. If you want to see the Excel file, I have something with me, that is the complete dump files and data. So if you go to malwareanalysis.net, you will find the malicious XLA, malicious XLA. But if you are doing the malware analysis still here, you have already gathered all the IOCs. As soon as you identify the malicious traffic from the dumped environment or the dumped PK files, make sure you block all the IOCs immediately, to stop the infection and run the complete EDR scans in your environment. So this is how we blocked it. Then, then we identify the malicious file as well, the email that was already identified. Then we created a hash of this particular file, a SHA-256, and we ran a complete EDR scan using the hash, so that immediately this file is being done. So let me just exit it from here. What I did is I have modified quick one scope, and to identify some things. Let me just first go to complete sudo quick one scope minus file malicious.xla, and here we go. As first of all, we'll do the VT check, that whether something is there on the virus total for this. And here we can see that this file is already being present on virus total with the name with the label progen.office x97m, which is very well known for your agent Tesla. And almost all the antiviruses have identified it. And what the CrowdStrike IDS has identified, the source IP addresses, then destination IP addresses, and what is the rule category under which this is being identified, and the rule source. So let's check if something else we can identify as, oh, sorry, we can extract the domains out of it. And we were able to extract one domain, which we know now is to download it, which was used to download the HTA file. So this is when somebody is double clicking the Excel, there must be some macro that has been embedded into that particular Excel file. Then macro might have ran, and it has downloaded the HTA file further. So let's check if we can, if in analysis something that we can get. Okay, so We did get something related to Visual Basic. It means there must be some macros inside this particular Excel file, and there is a bin file already here. Then we have the COM objects with 114 size. Then if something, okay, we have OLI objects as well. Okay, and this is something is interesting. So let's dump something if we can do it. Let's dump the macros. So if we dump the macros, we'll be able to come to know that there are three sheets in the file. Always remember that you perform first of the complete static analysis. Only then you should go for dynamic analysis. If you directly do the dynamic analysis, there might be many chances that you miss a lot of stuff from there. So always remember that you perform the static analysis completely, so that whenever you are going to perform the dynamic analysis, you know how the file is going to behave. Else, I have seen many incident responders who are performing the malware analysis. What they do is they directly go and start running the file. So what happens at that time is many a times we do miss the workflow, that how this particular malicious file is going to behave. So always remember that that as a good malware analyst, you first do the static analysis, you create the workflow, you create the chronology, that how this malware is behaving and how this malware is working, and only then you should go ahead and start executing the dynamic analysis. Now if you see that this particular Excel sheet has the, or Excel file if I'll say, has the this workbook sheet, where we have the global namespace something as almost false, some nothing is being identified, something interesting is not there, but we did find something else, xlm macro and xlm macro dot text, and we see that the file path is password protected. So what we can do, we can start extracting the files that we have already extracted from there, and let's see if we can extract something interesting out of it. So what I did, I kind of created okay. So let me first show you the HTA file. That is the very first file that was being downloaded, which is this. So as I showed you, this is the JavaScript code in which the something similar. If you see that this looks like to you URL encode, but this is not URL encode. There is a lot of encoding that is placed. So after analyzing a lot, and after spending a lot of time, we were able to identify some things out of it, but not everything. So if you see that we have created something with the code HTA file. And what we did in this, we first of all we imported the URL lib parse. Of course, we will use this. I have also added uh, the comments over it, that what we are presenting on this. So this is a very simple Python file, nothing fancy in this. So we entered the encoded data into this. Then what we did, we used the unquote function from the URL parse library on the encoded data. Then we parse the decoded data string, whatever is being identified, through the 16 characters per script logic. So then what we did the reverse shift to the data and the shift value. Then we store the result in the open string, and we created a for loop in which the character set is being identified, is being set into the data. so that whatever the data which is being characterized code between 32 bytes to 126 bytes, it run a function code char to 32 and then shift value to percentage 95 and add 32 bytes of the data in this. I will upload this particular Python file to my GitHub so you can download it from there, but nothing fancy. It's simple. Then we did a reverse shift in the reverse order and we decoded the data. So if you run this particular file, sudo python 3, then the code htfi, you will be able to identify a lot of garbage onto this. Okay. Then we did clean something out of it. So if yep, we remove the character G's and a lot of other stuff from this. And this is the interesting data that is being identified. So for an example, like here, some string is there, which looks very, very interesting. And we started doing a lot of mumbo jumbo onto this, that using these credentials to, to unlock the Excel file and, and many other stuff we did. And we come to a very big conclusion is to run the dynamic analysis after that. So I have run the dynamic analysis, but there is something that I identified on the virus total, which was very, very very, very interesting. So let me show you the virus total. This, let me create, I don't know if it is still there. So let me create hash of this particular file. Let's create the MD5 sum only. Malicious XML. So this is the MD5 sum. Let's go to virus total. Let's search for the MD5 sum, and here is we got the analysis. In you can go through the analysis, but what I wanted to show is the behavior. And I generally, you can download the artifacts if you want to. For an example, for oops, we have to authenticate. Let me just authenticate. Sorry, I paused the recording for a minute because I was logging into the account. So if you want, you can download the artifacts. I don't know why artifacts are not there, but you can download the reports. The report is very, very interesting for this. But I wanted to show the network connections onto this, the network analysis. Let me just first go to the. Okay, let's start from the from here only. No worries. So this is the agent Tesla malware that we have already seen, and this is the username and this is the password. What is the persistent file, and this is the external hosting where the everything was hosted. You can download the malware from the malware bazaar as well. That is also there. So what all things are being performed, that first it check the available memory, then it connects to the mining pool and it queries to the keyboard this thing. Whatever the basic malware does, this is what that malware is doing. Let me just go to this. So these are the dropped files. This is the discovered data. These are the payloads, but what interesting is the commands that ran at the back. Now I have also captured the commands, but when I was reading the report looks very, very good. So I thought rather than running the dynamic analysis and putting my machine and other things to risk, I thought to showcase over here. So the so this is the so this is the file that was being run in the macros. Then it of course an MSSTA was being run and then a PowerShell command was being run to to bypass the execution, and it was then device encrypted deployment or DXE was being executed, and a lot of encoding data was being performed. And this agent Tesla is very interesting when I was analyzing it, and you can see a lot of important data is being, important commands are being run over here using the PowerShell. You can see that they are being, you know, so you can in your so you can go through these commands. These commands are, and you can also run the dynamic analysis onto this, and you will see that that these commands were being run when you will do the perfect memory analysis. From you can use process hacker and then connect and then put a filter onto that particular file, and you can run the quick scope watch module, and you can see what all is being run at the back end, and you will thrill to see that what this agent Tesla was actually doing. So this was very interesting malware analysis that we did. So I thought to present, to everyone, and I hope you like this video. So keep hunting, keep uploading the IOCs, keep uploading the good researches, keep uploading all the data onto the to the community, and spread the knowledge as much as you can. Thank you, everyone.